Hello! Okay, third in series on simultaneous equations. Right, now this one is pretty much higher tier only. Okay, so if you're doing the higher tier paper, you may be forced with these nasties, but they're good fun. Okay, so what we've got two simultaneous equations here. We've got x minus 2y equals 3, and we've got x squared plus 2y squared equals 27. Now, as soon as you see those squares appearing in one of your equations, our previous method is not going to work. Okay, so we need a different method to tackle these sorts of simultaneous equations. Okay, and that method is called substitution. It's a bit like the second part of the method we've already used. Alright, now the trick to this method is we need to get one of our equations to say x equals or y equals or whatever the variable is. They might not always be x and y, we might have p and q in there. Okay, to get one of the variables as, in this case, x equals. So we're going to turn this equation 1 into something new. Okay, so we'll take equation 1 and we're going to rearrange it to get x equals. Okay, so to do that, we start with x minus 2y equals 3. And I think if we add 2y to both sides, we'll get x equals 3 plus 2y. So we've rearranged the equation, and now we've got x equals something. Okay, and that's the key starting point. Now what we're going to do is we're going to substitute that whole 3 plus 2y expression into our other equation, into equation 2, anywhere that an x appears. Okay, so let's rewrite out equation 2. Equation 2 said x squared plus 2y squared equals 27. But we now know from our other equation, that x is equal to 3 plus 2y. And it's that we're going to substitute into x into this equation. So x squared becomes 3 plus 2y squared. All we've done is replace the x with 3 plus 2y. And we've got plus 2y squared equals 27. Now I would strongly recommend, that means do it, at this point, that before you do any more, you expand, well, before you expand the bracket, you write out what that means in full. That means 3 plus 2y times 3 plus 2y. If you don't do that, you're much more likely to make a mistake. Okay, you'll forget some of the terms. Okay, so we've got 3 plus 2y times 3 plus 2y plus 2y squared equals 27. Now we're going to do some expanding. Now we're going to expand these two brackets here. And if we expand those, two brackets there, you can use FOIL, you can use your grid method. We're going to get, actually let's go through with FOIL. Let's just expand that. 3 plus 2y, 3 plus 2y. Okay, that's all we're dealing with. That's the bit in green. Okay, if you like the FOIL method, that's first times first, outer times outer, inner times inner, and last times last. Okay, so FOIL's not the method I'd go for, but let's go through them in that order. 3 times 3, that's the firsts, that's 9. Outers, that's 3 times plus 2y, 3 times positive 2y rather, that's 6y, so we get plus 6y. So we've done F, we've done O, we'll do inners. Inners is 2y times 3, that gives me plus 6y. And lasts, that's 2y times 2y, that is 4y squared, and do not forget that squared. 2y times 2y, not 4y, it's 4y squared. Okay, so we've expanded those brackets. Now we can simplify that because we've got 6y in there twice. That gives me 9 plus 12y plus 4y squared. Okay, so we've done our expanding. Right, now that was only part of our whole equation. So we'll now write 9 plus 12y plus 4y squared. And then we had plus 2y squared, so I'll add that on, equals 27. That's our whole equation. Okay, now we can simplify that. We've got 4y squared plus 2y squared. That's 6y squared plus 12y plus 9 equals 27. Right, so far so good. Okay, now in order to solve this, okay, we're going to treat this like a normal factorising quadratic equation. So we want to try and get one side equal to 0. Okay, so to do that, I think we need to subtract 27 from both sides. That's going to give me 6y squared plus 12y, and subtract 27, that's going to give me minus 18. Minus 18, I think, equals 0. So 6y squared plus 12y minus 18 equals 0. Now because we've got equals 0 on the right, we can do something clever here. We can divide through by 6, and it's going to make our factorising much easier. So we're going to divide through by 6. Okay, so we've got 6y squared divided by 6, that's y squared. 12y divided by 6 is plus 2y. Negative 18 divided by 6, it's going to give me negative 3, is equal to 0. And that's okay, because 0 divided by 6, we have to do the same on the right, still 0. So you can always do this with a quadratic expression that's then equal to 0. If it helps you, you've got a common factor on the left, divide through by it, because that 0 divided by that common factor will stay as 0. Right, we now need to factorise. Okay, so we could use our quadratic equation, but in these questions, often we'll be able to factorise them. So I'm going to try and solve this by factorising the left-hand side. Okay, so if I put two y's in there, that's going to give me the y squared. Right, I need two numbers in here that multiply to give me minus 3, and sum together, add up, sum to plus 2. So what are our factors that could make the 3? Well, we could have a 1 and a 3. Oh, that's it. Okay, that's all we can use, so it makes this one a bit simpler. Okay, now I want a negative 3, so I now have got to have a plus and a minus somewhere. So one of these is going to be plus, one of these is going to be minus. Okay, if we put plus 3 and the minus 1, that works out, because when I multiply these terms I'll get plus 3y. When I multiply these I'll get minus 1y, which will give me the plus 2y. If I'd have got my signs wrong, this wouldn't work out. If I'd have put minus 3, that will give me minus 3y plus 1y, we'd end up with negative 2y. So there's only one way those numbers can go in. Okay, what does this tell me? Right, that tells me that the solution to this equation is that y can be negative 3, or y can be positive 1. Now why is that? Well, to make this equation equal to 0, one of these brackets, either this one or this one, has to be 0, because if this one's 0, 0 times whatever the other bracket is gives 0. Yep. Or if this one's 0, 0 times whatever this bracket is gives 0. Yep. So the key thing is one of those brackets has to be 0, and to make the bracket 0, the whole expression in the bracket, y plus 3 to be 0, if it helps we can write it out, y plus 3 equals 0, we can see that y has to be negative 3. So really we're just looking for the number in there and then swapping the side. Y is negative 3 or y is plus 1. Okay, I've just cleared some space at the top so that we can now find what x is. Okay, so we've got to deal with two cases this time. We've got y could be minus 3, or y could be plus 1. Both of those satisfy these simultaneous equations. So now we'll go back to our starting equations, and just like in our previous method, the second step's the same. We're going to substitute that value back in so we can find the other variable, which in this case is x. So we're going to put y equals minus 3. I'm going to choose the simplest equation as always, which is x minus 2y equals 3. That's that equation. So we're going to take one of our starting equations, go for the simplest, and we'll substitute our value of y in. So we get x. Right, now I've got to be careful. I've got minus 2 times negative 3. equals 3. So that gives me x negative times this negative is a positive. I've got plus 6 here equals 3. And if I then subtract 6 from both sides, that gives me x equals negative 3. Okay, so I think that x could be, when y is minus 3, x is, negative 3, it's a bit wonky. Now let's do the same with the other side. Y equals positive 1. So again, we'll take the same starting equation, x minus 2y equals 3. And we'll put in y is plus 1, positive 1. So x, now this time minus 2 times 1, that's just minus 2, is equal to 3. And if we add 2 to both sides, that gives me x equals 5. So I think that when y is 1, x is 5. So we have two solutions to these simultaneous equations. We've got x equals minus 3, negative 3, y equals negative 3, and we've got x equals 5, y equals 1, plus 1. Okay, right, I'll give you a minute just to substitute those values back in. Right, you should find that when you substitute in x is negative 3 and y is negative 3, both of these simultaneous equations give the right answers. Those values satisfy those equations. And when you substitute in x equals 5 and y equals 1. So try that now, have a go, make sure it's okay, and then these ones take a fair bit of practice. So in your revision guides, the second page of Simultaneous Equations 2, is all about these trickier types. So I would strongly suggest you have a go at those. Good luck!